The scan operator applies a reducer function on each emitted value, joining new values emitted from the source to the current accumulated value. Scan then emits the new accumulated value. This is in contrast to the reduce operator, which only emits the final accumulated value on completion. To understand scan, let's start with an example from the previous lesson to see how it compares. Here we are creating an array of numbers, which we are turning into an observable of numbers using the from creation operator. We are then using the reduce operator to create a sum for the numbers being emitted. Instead of storing the reducer function in its own variable, like the previous lesson, we are instead supplying it inline. Then we are simply logging values emitted from reduce to the console. When we run this, we can see 15 is logged, which is the result of the accumulator function being applied to each emitted value. The observable then completes, and reduce emits the final accumulated value, which is the sum for the values contained within the numbers array. To see how this compares to scan, we simply need to replace reduce with scan. Let's go ahead and import scan from rxjs/operators. Now let's swap out reduce with the scan operator. Nothing else has to change because the signature for reduce and scan are actually the same. Let's run this and see what it looks like. We can see that for each emitted value from the numbers observable, the new accumulated value is emitted. Unlike reduce, scan does not wait until the observable completes before emitting the accumulated value. On each emission from the source, the accumulator function is run and the result is emitted. This can be incredibly useful when you need to act on or display state that is being accumulated over time based on an event. For example, suppose we wanted to manage some global state within our application with observables. For the sake of example, I'll just pretend we have a user object that we need to keep track of as the state of the logged in user changes. For now, I'll just create an array of different user objects to represent these changes, but in reality, these would probably arrive over time through some user event or interaction. Next, let's update our observable to be an observable of user objects rather than an observable of numbers. We'll then need to update the seed value to be an empty object. Finally, instead of simply adding the accumulator and current value, let's update this to use the object spread operator to return a new object with new or updated values on each call. When we run this, we can see the state being updated accordingly, emitting the latest version of the user object on each emission from the source. Now, suppose we wanted a stream of just the username for display somewhere in our app. We know now from previous lessons that when we want to grab a property from an object being emitted, we can use the map operator. Let's go ahead and import that now from rxjs/operators. Next, we will assign the stream of user state changes to a constant named state. We can go ahead and remove this subscribe for now. Let's then create a const called names, which will be a reference to our stream of names. We can then use our state stream and supply the map operator. Remember, the map operator takes a function which accepts the emitted source value and returns a transformation of that value. For now, all we need is the name property from our state object. Finally, let's subscribe to the name stream and run this. We now have just the name property being logged. If you're familiar with Redux, you may recognize this pattern of building up state over time as familiar. With RxJS, you can actually build a Redux-like solution with just a few operators. In fact, if you were to hide this behind a subject, which we'll learn about in a future lesson, and add a helper called select, which creates this map behind the scenes, you are starting to get dangerously close to some of the initial implementations of NGRX Store, Angular's preferred Redux solution. A couple of caveats I want to point out before we end this lesson. You may have noticed this value is logged 3 times even though it never changed. There are actually some operators to handle this scenario that we will learn about in a future lesson, which will only emit values that do not equal the previous emission. Lastly, since each subscription creates its own execution path, creating slices of state, like our name stream here, would cause the scan operator to run multiple times for each update based on how many subscriptions we have created. There are also ways to manage this by sharing a stream execution among multiple subscribers, which we will also touch on in a future lesson. To recap, the scan operator allows you to accumulate state over time, applying a reducer function on each emission from the source, omitting the result. If instead, you only need the last accumulated value on completion of the observable, you can use the reduce operator.